So this is question 10 from the sample assessment materials, and this is the last question on the paper. It's a projectiles question. So we've got this stone being thrown with speed u meters per second from a point O at the top of a vertical cliff. The point O is at 18 meters above sea level. The stone is thrown at an angle alpha above the horizontal, where tan alpha equals 3/4. The stone hits the sea at the point S, which has a horizontal distance of 36 meters from the foot of the cliff. And the stone is modelled as a particle, and we're supposed to take G as 10 meters per second squared. So part A wants us to find U. Now, this speed U, to start with, can be split up into horizontal and vertical components. So we've got this U here, and we've got the vertical component there. So we've got U cos alpha and U sine alpha. Now we actually know cos alpha and sine alpha because we know that tan alpha equals 3/4. So if we draw a little right angle triangle, tan of alpha opposite over adjacent, that would be 5. So we know that sine of alpha is equal to opposite over hypotenuse, so 3/5, and cos of alpha adjacent over hypotenuse is 4/5. So this U cos alpha is 4/5 U, and U sine alpha is 3/5 U. Now we're going to, when we deal with projectiles questions, we have the horizontal and the vertical, and we're going to split the whole problem up into horizontal and vertical. So let's start with horizontal. And we're using our constant acceleration formula here. So the really important fact about this is that the acceleration in the horizontal direction is 0. Okay, it doesn't change. The speed does not change in the horizontal direction. But we know that the distance it travels is 36. So S is 36. And we know that U, the horizontal U, is 4/5 U. And vertically, I'm going to do the same. So I'm going to take the distance, the initial movement, as positive. So I'm going to take up and right as positive. So overall, it goes down 18 meters. So the vertical S is -18. U is -3/5 U. And V we don't know. A is -10. Oh, I've just realised that I've written -3/5 U there. That should be positive, just imagined the negative. So the initial U, initial velocity is 3/5 U. So now we're going to set up an equation for the horizontal and vertical motion. So we're going to use the constant acceleration formula, S equals ut plus 1/2 at squared. So for the horizontal, it's 36 equals 4/5 ut, and this part is 0 because A is 0. And over here, for the vertical, it's negative 18 equals 3/5 ut plus a half negative 10 t squared. So let's tidy this up. So I'm going to rearrange that for t, to make t the subject, and then I'm going to substitute it in here. And then I will only have an equation in u. So rearranging this, multiply by 5, divide by 4, I get 45 equals ut. So t equals 45 over u. And then I'm going to substitute that in here. So negative 18 equals 3/5 u 45 over u. Plus a half times negative 10 is negative 5. T is 45 over u all squared. Those u's cancel. So if I tidy this up a little bit, I get negative 18 equals 45 divided by 5 times by 3 is 27 minus 5. I'm going to leave that at the moment as 45 squared over u squared. So let's just subtract 27. So I get negative 45 equals negative 5 45 squared over u squared. Going to multiply by u squared now and by negative 1. So 45 u squared equals 5 lots of 45 squared. So 45 squared times by 5 divided by 45 is 225. So u is the square root of 225. So it's 15. So that's part A done. Part B wants us to find the speed of the stone when it's 10.8 meters above sea level, giving your answer to two significant figures. So if it's 10.8 above sea level, that means that it's fallen 7.2 meters. So we're going to set up our constant acceleration, our SUVAT again. So we want to find the horizontal and the vertical and then take the magnitude of that to find the speed. Okay, so the horizontal and vertical velocities and then take the magnitude of it. So horizontal, we don't know that, but u is still that, because we know that u is 15 now. So rather than being 4/5 u, it's 4/5 times 15. V A is still 0 because we're horizontal, and T. So V equals u plus AT. A is 0, so V equals u. V equals 4/5 times 15, which is 12. Because it doesn't change, the velocity doesn't change in the horizontal direction. Now vertically, S, it's fallen 7.2 meters. U is 3/5 u, so 3/5 times 15, which is 9. V, we don't know, that's what we're trying to find. A is negative 10, and T we don't know. So we've got SUV and A. So the equation we can use is V squared equals U squared plus 2AS. So V squared equals 9 squared plus 2 times negative 10 times negative 7.2, which is 225. So square root both sides, square root of 225 is 15. So the vertical velocity and the horizontal velocity we've got now. And then to find the speed, we just take the magnitude of those. So we've got it falling, it's going 12 in that direction, 15 in that direction. We want to find that. So the square root of 12 squared plus 15 squared, which comes out, that's the square root of 369. And to two significant figures, that is 19. So part C, last part of the paper, says suggest 2 improvements that could be made to the model. So the 2 improvements I would make are, they've told us to take G as 10. So take G as 9.8. That would be slightly more accurate. And then the other improvement I could make is to take into account, we've modeled it as a particle, so there's no air resistance. So we could include air resistance in the model.